Welcome to our second moment class. In today's class, we will start with the principle of moment. Now, the principle of moment states that the sum of the clockwise movement about a point is equal to the sum of the anticlockwise movement about the same point. That is, if a body is in equilibrium at a point, all the clockwise movement in that point, the sum of all the clockwise movement will be equal to the sum of the anticlockwise movement. Now, one of the things that is difficult to most students is how to know which of the bodies or the forces rather undergoing clockwise movements and anticlockwise movements. The first thing to know, when we say something is clockwise, we are saying in the direction of the clock. How does clock move? Clock always move in this direction, that is clockwise motion. But when we say something is anticlockwise, it moves in the reverse direction, that is move counter to clock. In the opposite direction of clock is what we call clockwise movement. Now let's look at which of these two forces that is undergoing clockwise movement and anticlockwise movement. Now, for us to determine clockwise movement, we know that the rotation of the body is in the knife edge. That is, this is the point of rotation. So, for you to determine, let's start with the force F1. Now, this is the direction of the force what? F1. This is the direction of the force 1 going down like this. So, for us to get the clockwise movement, we will move this body in its direction. We move this body in its direction. The force, not the body. We move this force in its direction towards knife edge to the end of that force. So let's put an arrow in our direction of motion. You can see that this motion, this movement of the force F1 is anti-clockwise. Now let's do the same for the second force F2. We move it in its direction towards the rotation point. We can see that it's moving out in the clockwise movement. It's showing clockwise movement. So this is clockwise in the direction of clock. So now, in a simple way, we can what? We can say that this is what? This movement is what? Anti-clockwise movement. Then we can say this movement in this direction is clockwise movement. Clockwise movement. Now let's still look at another example, because we must know clockwise movement and anti-clockwise movement very well in order for us to be sound in our calculation. In this system, let us assume that our knife edge is at this point. So let's go through our previous exercises again. If we drag this body, this F1 in its direction towards what? The knife edge. Let's put our arrow. How is it moving? It's moving like this. So which means the force F1 is producing what? F1 is producing anti-clockwise movements. Now, let's still look at F2. F2 is moving just like this. That is, this direction is what? is this direction is clockwise. F3 is clockwise movement. Now let's look at F4. F4 will move like this. That is in this direction, which is what? Anti-clockwise. F4 is anti-clockwise. Now, what about F2? If you drag in the direction of the force towards the turning point, what would that be? That would be what? Clockwise movement. So in this system, you can see that the forces F1, F4 is undergoing anti-clockwise movement if the knife edge is in that position, while F2 and F3 is undergoing what? Clockwise movement. Now I want to move the knife edge to a point like this, that is assuming that this is where the body undergoes rotation. Now, if we move this F1 in the direction of the force and pass through the knife edge, we can see how that line is moving. It's again, how does it move now? It's moving anti-clockwise. So in this second movement, F1 is anti-clockwise movement. Now if we drag F3 in the direction like this, again we are moving what? Anti-clockwise. So this time F3 is what? Anti-clockwise. Now let's remove those drawings so that the second two can be clear. Don't forget that our knife edge is at this point. So we do for F1 and F3. Now let's look at F4. F4, you drag in the direction of F4 to the knife edge like this. As it moving, it's moving like this. So again, that is what? Anti-clockwise. F4 is anti-clockwise. Now what about F2? In the direction like this to the force, like that is moving out. That is moving clockwise. So only the force F2 that gives us clockwise moments. So you can see that the concept of clockwise motion depends on the point of rotation. So if the point of rotation changes, then the movement will also change. Now let's assume that the knife edge is at this spot, at this point. If we move F1, F1 is moving like this, which is what? Anti-clockwise. F1 is anti-clockwise movement. Now, F3 moves like this. F3 is clockwise movement. Now, F4 moves like this. Again, that is what? Clockwise movement. F4 is clockwise movement. Now, F2 will move like this. So we can see that the movement depends on where the rotation is, or where the assumption of rotation is. So that is on what? On clockwise movement and the anti-clockwise movement. Now the next thing we'll be dealing with, we want to deal with the conditions for the equilibrium of parallel coplanar forces. This is not for, this is of parallel coplanar forces. Now, what are parallel coplanar forces? Now, if you look at this diagram, this plane is what we call, in this case, that is the what? The plane. Now, all the forces lies on the plane. The forces F1, F2, F3, F4 lies on the plane. So those forces are called coplanar forces because they are on the same what? On the same plane. Why do we call them parallel? Each of the forces are parallel to each other. Because they are parallel to each other, we say they are what? Parallel forces. Because they are on the same plane, so they are coplanar what? Forces. So these forces F1 to F4 are parallel coplanar forces. Now, for parallel coplanar forces to be in equilibrium, the principle number one, the principle of moment must hold. That is, if we choose any point, let's say this point, the sum of the clockwise moment in this point is the same as the sum of the what? Anti-clockwise moment about this point. Now, the second condition is that the algebraic sum of the forces in one direction must be equal to the algebraic sum of the forces in the opposite direction, which means that now the sum of the forces going down must be equal to the sum of the forces going up. So that would be F1 force plus F2 force, which is going down, must be equal to F3 plus F4 force that is going what? Up. So that is the condition for equilibrium for parallel what? Coplanar forces. Now let's look at non-parallel coplanar forces. What is the condition of their equilibrium? Now, non-parallel, if you look at these two forces, F1 and F2 lies on the same plane. So they are what? Coplanar. But they are not parallel to each other, so they are non-what? Parallel. So this system is dealing with non-parallel coplanar what? Forces. Now, how do you deal with non-parallel coplanar force? The first thing is to resolve that force that is not parallel. This is the opposite of the force. That will be F1 sin theta. And this is the adjacent. That will be F1 cos theta. You know that in our last class, we have said that the force F1 cos theta, in this case that lies on the plane, will not produce moment. So all that we have to do now is to indicate the forces. This force F1 is F1 sin theta is going up, and F2 is going down, and we have what? Our knife edge here. So we have to resolve that. So now the first thing is that if we are taking moment at this point, the principle of moment must hold. That's the first condition. Now the second condition is that the resolved vector sum of all the forces acting on the body must be what? Must be equal to 0. So now that we have resolved this force, the one going up and the one going down must what? Must be equal for the body to be in equilibrium. For the body to be what? In equilibrium at that point. So we can say if the system is in equilibrium, that the turning moment here must be equal to the turning moment, the clockwise moment and the anti-clockwise moment must be the same, and the resolved vector sum of all the forces acting on the body must also be equal to 0. Now let's look at the center of gravity. The center of gravity of a body is defined as the point through which its resultant weight acts. That is, where the resultant weight of a body acts is what we call the center of gravity. If we look at the characteristic number 1, so the characteristic of the center of gravity of a body number 1, it is the point where the resultant weight of an object acts. 2, it is related to the stability of an object. That is, bodies with low center of gravity are always very stable. It depends on the shape of an object, depends on the shape of the body. So the center of gravity of a body that is circular is not the same as that of the body that is rectangular. Now, the center of gravity of a circular object is at the center of the circle. If an object is circular, the center of gravity is at the center. It is not always at the middle of an object. Now, it depends. If the object is uniform, you may get it at the middle. If it is not uniform, if it is non-uniform, it will not be at the middle. The center of gravity of a square or rectangle is at the point of intersection of the diagonals. So if you have a rectangle like this is diagonal 1, and this is the second diagonal. Now, this point is where the center of gravity of that object lies. Now, the center of gravity of a uniform rod is at the 50 centimeter mark. So, whenever you hear that a rod is uniform, now normally a uniform rod is 100 centimeter. So, the center will be 50 centimeter. That is where the center of gravity will be if the rod is uniform. Now, the center of gravity of a uniform rod coincides with center of mass. Now, there is center of gravity and there is center of what? Mass. The center of gravity of a non-uniform rod does not coincide with its center of mass. So, if it is uniform, the center of mass and center of gravity will be the same. If they are non-uniform, the center of mass and the center of gravity will not be the same. Now, let's look at the center of mass. The center of mass of a system of particles is the point that moves as though all of the system mass were concentrated there and all external forces were applied there. So the only thing that center of mass adds is that, center of gravity is where the resultant weight are. That is where all the mass of that body is concentrated. So we can see that that is the first condition in our center of mass. But another condition that is added to center of mass is that all the forces, the external forces, must also be applied at that point. So the center of mass of a body. First is the center of gravity. The second is the point where all the external forces of the body act. One thing I want to bring to your notice is that the vertical line through the center of gravity of a body is always through the base of the body. So if you draw a vertical line through the center of gravity of a body, it will be through the what? The base of the body. Then you can read the rest condition there. Now, these lectures are coming in bitwise. In order for us to comprehend it, you can take note. This note is, the lecture is very comprehensive. You can write your note down. Our next class, we will now be focusing on what? On calculations. We have taken all the conditions, all the things we need to know in order for us to be effective in calculation. So the first two lectures are very important. To the third one, we'll be taking on the principle of moments. So please master every aspect of the lecture, of the first two lectures, because our third lecture will depend on it. Thank you.